Welcome to Study Loop.
Problem 8.69. So we have these three balls that are colliding with each other, and then they're sticking together. And what we want to know is what is the magnitude and direction of velocity that ball C here needs to have in order for the combined three balls to be moving off at half a meter per second in the x direction after they collide. So we're told the masses of these. Point 0.03 kilograms and 0.05 kilograms. Now these are moving around on a frictionless table, so we know that the total momentum is going to be conserved. So actually, let's just call the total mass large M, and then the final velocity we'll just call V, since all the other velocities are going to have subscripts on them. Save ourselves a little bit of writing. And so this is going to be the sum of the momenta before the collision. And this is what we'd like to know. So let's do x first. This is a colon. So VCX is going to be equal to 1 over MC times MVX. This is going to be our half meter per second that we're wanting to see at the end, minus MA VAX minus MB VX. So B is coming in at an angle. We can see that this is at 60 degrees to the x-axis. So this is, you just use the trigonometry to find the components of this. So, this will be a cosine. It'll be negative because it's pointing in that direction. So really, if you were wanting to find the actual thing, you'd put B here, and then it would actually be 180 degrees plus 60. And so the cosine would be negative. Or you can just save yourself the bother of thinking about that. It's not really that much more bother. But anyway, you can just put the negative sign in front of the cosine of 60, and it works exactly the same. So then doing that, we find that this should be 1.75 meters per second. And then this is going to look pretty much the same, except with y's everywhere. So now m, big M, Vy minus Ma, Vay. Now, A is not moving at all in the y direction. And the desired Vy of our, or the desired y component of the velocity of the three balls after they collide is 0 minus mb vby, which will again be negative, so this will end up being positive, and this will be negative sine of 60 degrees, will be what you want for that. And so then this is 0.260 meters per second. So far, so good. So for the kinetic energy, we need to know the magnitude of this vector. And like with all vectors, its magnitude is the sum of the squares of its components. So this is 1.77 meters per second. So now delta K is, of course, the final minus the initial. This is 1/2 big M v squared, then minus 1/2 MA VA squared plus MB VB squared plus MC VC, which we just found, squared. And this being a completely inelastic collision, or indeed for any inelastic collision, we expect this to be negative. And fortunately for us, that is exactly what happens. So it's negative 0.092 joules.